Hello and welcome to my science tutorials. In today's video, we want to look at solving quadratic equation by the method of factorization. So let's begin by looking at an example. So assuming we have x squared minus 40x minus 6000 is equal to 0. How do we go around solving this particular quadratic equation to get the roots of this equation? Alright, so the first thing we do is normally quadratic equation is of the form ax squared plus bx plus c, where c is the constant. Now for us to rewrite this equation in a much more easier way to factorize, we first of all use the coefficient of the x squared term to multiply the c term. The result that we get, we try to find two numbers that we can either add or subtract to get the middle term over here, which is b. So let's look at that. If we multiply 1 by negative 6000, it's going to give us negative 6000. Now, which two numbers can we add or subtract to get negative 40? But if we multiply them, we get negative 6000. Alright, if we look at negative 100 and 60, that will do the job. Negative 100 multiplied by 60 will give us negative 6000, which is what we get after multiplying the coefficient of x squared by negative 6000. And then if we add these two, we are going to get negative 40, which is in the middle, and that is what we want. So we can rewrite this whole equation as x squared minus 100x plus 60x minus 6000 is equal to 0. So if you look at this, we haven't done anything to the top equation. It's just that we've rewritten it in a much more easier way for us to factorize and get the roots of this equation. Alright, so between this term and then this term, we realize that there is x common, so we can factor out x. So if we do that, we have x outside, x minus 100 here. So if we expand this bracket back, we'll get what we have at the top here. Then plus, between this and this, we can say that 60 is common, so we factor out 60 into bracket x minus 100 here will give us the 6000 we have at the top over here. So we can see x minus 100, x minus 100, that becomes our common factor. So we only write one of it. So x plus 60, we are going to write this as 1. So x plus 60 as one of the factors, and then x minus 100 as another factor. So from here, we equate each of these two factors to 0 to get our answer. So we have x plus 60 equals 0, or x minus 100 is equal to 0. So from here, we have x is equal to negative 60, or x is equal to a positive 100 as our answer. Now, this x is equal to 60 and x is equal to 100 are what we are calling the roots of the equation. That is, they are the values of x that satisfy this particular equation. So if we substitute x equals negative 60 back into this equation, we are going to get 0. And if we substitute x equals 100 into this equation, we are still going to get 0 as our answer. Right, so let's proceed to look at another example. Now, this is a particularly interesting example. We are to solve x power 4 minus 13x squared plus 36 is equal to 0. Now, wait. This is not what we sign up for. We are here to solve quadratic equations raised to the power 2. How come we have quadratic equation raised to the power 4? This is going to be difficult. Now, there is an easier way for you to solve this without having to go through any hassle, and that is what we are going to do. So we just need to rewrite this equation in a way that we can have s squared term to be represented by another variable, and then we solve it and get our answer. By that, I mean I can rewrite x power 4 as x squared squared, and that still give me x power 4. Okay, so I've not done anything to the equation. Then I repeat the remaining terms here, plus 36 is equal to 0. So I've not done anything to the equation. I've just rewritten x power 4 as x squared squared. Right now, from here I can say let x squared be equal to y. So it means wherever I see x squared, let me replace that by y. So over here I'm going to have y with a square here at the top, minus 13, then this x squared become y, plus 36 is equal to 0. Now this is looking like our normal easy quadratic equation that we can factorize. So we go ahead to factorize this and get an answer. So we multiply the coefficient of the y square here, which is 1, by 36. That will still give us 36. Now which two numbers can we multiply to get 36? But if we add them, we get negative 13. So negative 4 and negative 9. If we multiply these two, we get positive 36, but we add them, we get negative 13. So we are going to write this as y squared minus 4y minus 9y. It doesn't matter whether you write the 9y or the 4y first, it doesn't matter because you're still going to get the same thing. Then plus 36 is equal to 0. So from here, I can go ahead and factor out y over here. So I factor out y, I have y into bracket, y minus 4 over here. So y multiplied by y will give me y squared. Y multiplied by 4 will give me negative y over here. Alright, so over here I have minus, between 9 and 36, 9 is common, so I factor out 9, then into bracket, y minus 4 is equal to 0. So I can now write this and this, so I have y minus 9, y minus 4 is equal to 0. Right, so from here, I can proceed to have y minus 9 is equal to 0, or y minus 4 is equal to 0. So let me erase these guys so that they don't confuse us. Okay, so from here it means my y is equal to positive 9, or my y is equal to positive 4. But now remember, we were not asked to find y, we were told to find x. We decided to introduce another variable we are calling y. So we need to bring that condition back. But we said that s squared is equal to y, which means s squared is equal to the 9 over here. So to find x, we take the square root of this. So we remember to introduce your plus or minus, because whether positive or negative, you're still going to get the same answer. So our x is equal to plus or minus 3 over here. So whether it's positive 3 or negative 3, if you square that, you're going to get 9. Alright, so this is our answer for the first option. The second one is, we are still going to write y squared is equal, s squared is equal to y, then s squared is equal to 4. Okay, so from here, we take the root of both sides. So we are going to have s is equal to plus or minus the root of 4, and that will give us s is equal to plus or minus 2. Okay, so it means whether you square positive 2 or you square negative 2, you are going to get 4. So our answer now, the values of x is equal to, so s is either equal to negative 3, negative 2, positive 2, or positive 3. So these are the 4 values that will make this entire equation equal to 0. So you can see that the x term is raised to the power 4, and then we have 4 answers at the end of finding the values of x. So if it were to be s squared term, just s squared, we are expecting 2 answers. If it's s cubed, we are expecting 3 answers. That is how quadratic equation works. If it is x power 4, we are expecting 4 answers for that particular equation. Alright, so let's go ahead and look at another example. So we have to find the real roots for the equation. So find the real roots of the equation x squared minus 2 is equal to 8 on x squared. Alright, so let's go ahead and try to find the root of this particular equation. So we have s squared minus 2 is equal to 8 on s squared. Alright, so from here, the first thing we need to do is to get rid of the denominator over here, because we want to have this in a linear way. Rearrange it to get a quadratic equation before we can proceed to solve. So I have s squared as the denominator over here. So if I multiply through by s squared, I can get rid of the s squared over here. So I multiply through multiply through by s squared. So if I do that, I'm going to have s squared multiplied by s squared minus 2 multiplied by s squared is equal to 8 on x squared multiplied by s squared. So s squared multiplied by s squared, that will give me x power 4 minus 2x squared is equal to this, we cancel this, so it's equal to 8. So I can rewrite this equation as x power 4 minus 2x squared minus 8 is equal to 0. Now I have this equation in a linear way, in a linear form. I cannot proceed to try and factorize this equation. Now, as usual, you can see over here that we have x power 4, and that is not what we want. This way it is a little bit complicated to solve it by factorizing, but there's an easier way to do it. That is to rewrite this as x power s squared minus 2s squared, just like we did in the previous example. Then I say let y be equal to x squared. So it means this whole equation becomes y squared minus 2y minus 8 is equal to 0. Now this way I can solve it much more easier without having to do any long division. So I have y squared minus 2y minus 8 is equal to 0. From here, I multiply the coefficient of the y squared term, which is 1 by 8. So it will give me negative 8. Now which two numbers will I multiply to get negative 8? But if I add them, I'll get negative 2. Alright, so if you look at it, 2 and 4 will do that, but one of them has to be negative. So negative 4 and positive 2 will give you negative 8, but if you add them, you get negative 2. So I have here y squared minus 4y plus 2y minus 8 is equal to 0. So I can factor y out here. So I have y outside bracket, then y minus 4. Okay, if I expand this, it will give me what I have at the top here, plus between 2y and negative 8, 2 is common, so I factor out 2 into bracket, y minus 4 is equal to 0. So I have from here y plus 2, y minus 4 is equal to 0. So I have y plus 2 equals 0, or y minus 4 is equal to 0. So I have y is equal to either negative 2 or y is equal to positive 4 over here. Now remember, you introduce y, so you need to go back and do the substitution. But you said that s squared is equal to y, so s squared is equal to negative 2. So s will be equal to the root of negative 2. Now the root of negative 2 will give us complex numbers. So this has no real solution, so we have no real solution for this particular first term. But the second term, s squared is equal to 4. So if we take the root of 4, you're going to have, this is plus or minus the root of 4. X will be equal to plus or minus 2. So for this particular equation, the real roots, instead of having 4 answers, the real roots, that is the real numbers that can make this equation to be equal to 0, is plus or minus 2. This is our answer as we've obtained from this side. Alright, so let's have a look at one final example. Alright, so we are to find the real root of the equation. So find the real roots of this equation. So we have 3x squared minus 5x plus 2 is equal to 0. Now this is very easy. You can try your hands on it by pausing the video, try and solve it, and let's go. Alright, so the first thing I always do, like I said, is to use the coefficient of the s squared term to multiply the constant. So 3 multiplied by 2 will give me positive 6. Now, which two numbers will I multiply to get 6? But if I add or subtract them, I'll get negative 5. Alright, so 3 and 2. Negative 3, negative 2, if you multiply them, you get 6. But if you add them, you get negative 5. So we'll go with that. So you have 3x squared minus 3x minus 2x minus 3x minus 2x will give you minus 5s plus 2 is equal to 0. So from here, I can go ahead and factorize. So over here, 3x is common. So I factor out 3x into bracket x minus 1. Then over here, 2 is common. So I minus 2 into bracket x minus 1 is equal to 0. So negative 2 multiplied by x will give you negative 2x. Negative 2 multiplied by negative 1 will give me positive 2. So I have here 3x minus 2. Then I have x minus 1 is equal to 0. So from here I have 3x minus 2 is equal to 0, or x minus 1 is equal to 0. So from here I have 3x is equal to 2. So I divide both sides by 3 to make my x stand alone. So my x will be equal to 2 on 3. Or from here I move negative 1 to the other side of the equal to sign, it becomes positive 1. So my solution for this particular equation is s is either equal to 2 on 3 or positive 1. This becomes my real roots for this particular equation. So thank you so much for watching. In the next video, we'll be looking at how to factorize complex quadratic equation raised to the power x raised to the power 4, power 6, power 5. You're going to look at them and see how we solve them in a much more easier way rather than using the complex method that is available. So thank you once again for watching, and I will see you in the next video. Bye bye.